Welcome back to class number 78. See, from today I am starting simply support beam with combination of point loads, UDL and UVL. Like point load and UDL. Instead of telling concentrated loads, I am telling point load. Point load and UDL already over. Plenty of questions over. See earlier. Now, point load with UVL. See today's class. UDL with UVL. Then point load, UDL and UVL. As I told you, this course is a complete coverage. So all these if you go through, day by day, your knowledge level will become quite high and you will achieve lot of, what you can tell is lot of control on the subject. Okay. Now, first see this question. First do one thing. Before starting further, see for those who are not interested about some logic or etc., skip this portion. Wait for a little time. See. If uniformly varying load is like this, if no other load is there, your BMD will be like this. See, maximum BM will be at L by root 3. That you already know it. L by root 3 equal to, for this question, it will be 10 divided by root 3. This you already know. 5.7735 meter. And this maximum BM will be W into L square divided by 9 divided by root 3. Okay. Now, 577.35 is the maximum PM. Okay, now it will take place slightly after center. Why after center? Because load is more this side. If the same UL is this way, it will come to left of center. This all already over earlier. Okay, now what I will do is, I will go for UVL with point load. See, the moment point load comes, beam bending will become more. It is already bending due to UVL plus point load. So, your maximum BM has to be more. It will become more. Also, the point where maximum BM will take place depends upon where is the point load. See, if I apply a point load that side, then more bending will come that side. Therefore, it will become more than 5.7735 meter. Say 5.7735. If I put a light load, 5.8. If I increase that load, 5.9. 6 meter, etc., etc. Okay, now, or if I apply the load somewhere here, then maximum BM point will be shifted to left side. Means what? It will come less than 5.7735. So, what I am going to do is, this question I will solve 3 times now. Today's class, I will put a point load here. I will see that maximum BM will come somewhere between these 2 points. Next class, it will be exactly under the point load. Next class, I will see that I will shift the load this side and maximum BM will come to right of that point load. So, thoroughly it will be covered. Now, one important or interesting point. I told just now, depending upon this value of the loads, maximum BM point will be, that point distance from here will be more than 5.7735. Now, today I want it to be a round number. Why means just like that? Or what I am telling now is just to show you, if you got good control, you can play with the subject. But don't have overconfidence. You can actually play. See, I will place a load W here. How much I am not told still. I will do one thing now. See, 5.7735. I want to be a round number. Say I want 6 meter. I told I want 6 meter. Means I want maximum BM to come at 6 meter. Now I will get it. Sometimes people will tell how it is possible, so many combinations, any random value will come. No, it is in your hand. If you know the basic concept and thorough idea is there, you can do whatever you want. See, I will tell you how this load I kept pending. See, 90 kN per meter, 10 meter, 3 meter, randomly load. Still I don't know what is that load. What is that load? Still I don't know. I told today I want maximum BM somewhere to left up load, somewhere here. Of course, it will be after center. See, I told if the point load is not there, 5.7735, I want it to be 6 meter. Okay. Now, I am committing now. I want it 6 meter. So, what I will do is, see, I will explain how I set the question. Otherwise, people will think, oh, he already solved earlier. He got that answer. Now, he is telling us to fool us. No. I will tell you how I got. You can also try. See. This reaction due to only UVL is 150 kilonewton. Why means 90 into 10 is 900, by 2 is 450, 1/3 here, 2/3 here. And this, because of this point load, this reaction is that point load into 3 by 10 is 0.3. Now, this value I want equal to, see this reaction, somewhere here I want shear force to be 0, so that reaction should be equal to this much load, that intensity of load there equal to 90 by 10 into x. 90 by 10 is equal to how much? 9x. Half into x into 9x is, it is 4.5 x square is the total load. Now I want x equal to 6 meter. So therefore, what I will do now? 4.5 into 6 square, it came 162. I'll subtract 150. I'll divide by 0.3. I got answer 40 kilonewton. I know round number will come. Reason, mathematics. 40 kilonewton. So I am going to put a load of 40 kilonewton here. Now the beam has to give the answer. That is, maximum BM should be at 6 meters from here. That is the point where shear force is 0. Guaranteed. Remember now, I want that x value later to be 6 meters. My commitment. Okay. If you understand, okay. Otherwise, leave it. Otherwise, do one thing now. Take the question. A simply supported beam. I'll remove all this one. See, I'll remove all this one now. This is only for understanding. It is not to boost my capacity. It is just to show what miracle you can do in structural engineering if you understand everything. Okay. Question. A simply supported beam of span 10 meter is loaded by an uniformly varying load of intensity 0 at left end and maximum of 90 kN per meter at right end, along with the point load of 40 kilonewton at 3 meter from right end. Draw SFD BMD. Okay, start. Solution. Calculate support reactions. How much load I got? Load is 40 kilonewton. These all I am not telling now. Minus VB into 10 plus half into 10 into 90 into, for the entire triangle, resultant will be somewhere here, 2/3 from here, 2/3 of 10, and then that point load 40 into 7 equals 0. You get the value of VB. VB will come half into 10 into 90 into 2 by 3 of 10 plus 40 into 7 divided by 10 will come 328 kilonewton. Okay. 328 kilonewton VB. Sigma V0 upward positive plus VA plus VB minus 40 minus half into 10 into 90 equals 0. You get the value of VA. From 328, I subtract 450 and 40. I will get plus 162 kilonewton. Okay. Now reactions are over. Now onwards, see, these all I will not explain. If a comment comes, not explain, I will tell roughly. Roughly means not that way. I have got right. So much explanation given earlier. Why you can't go through all the classes? Those who want to learn from me should learn or should go through all the classes. I told this is a complete coverage of SFD BMD. Further I will not tell, but some will tell this you are taking every time. Yes, just to give information. Okay, start. Now, before going further, don't go to SFD BMD. See, here A, B are the standard point. Even C also is standard point. Why? That is where point load is there. Therefore, to draw SFD BMD, there are 3 standard points, A, B and C. So, we need intensity of UVL at C. Get it now itself and then go to SFD BMD. See, that the intensity equal WC. So, 90 by 10 equal to WC by 7. You get WC 63 kN per meter. I should not tell further because mathematical concept class number 3. Over. Now, ready for SFD BMD. Okay, I will go for, what I will do is, some important principles are there. So, I will draw the SFD BMD because if I draw in front of you, sometimes the curve will not come properly. So, if I draw it, it becomes easy for me. Okay, now, 6 meter, remember, I made a commitment. It will be fulfilled. Okay, now, we are ready for SFD and BMD. Write the neat sketch of the beam here, somewhat to scale. I entered that 63, reactions over. Draw SFD BMD. I will do one thing now. See, shear force calculations I told are done as an academic purpose or to make complete solution. I told you can solve or you can draw the SFD without writing any calculation. Start now. Style. Go up by 162. See, already know it. from here to here come down by half into 7 into 63. See, half into 7 into 63 equal to, I don't know where is the calculator. I kept the calculator somewhere. Here. Okay. Half into 7 into 63 is 220.5. So, you go up by 162. From 162, subtract 220.5. You will get minus 58.5. Then, suddenly come down by 40. 98.5. Again, gradually come down. That is not gradually, sorry. Parabolically come down by how much? 63 plus 90 divided by 2 into 3. That is the total load. It will come 328. Now, as you remember, AC, C is a standard point. For AC and CB, parabolic variation of second degree. One important now, see. Important, see. At A, intensity of load is 0. So, if you draw tangent here, 0 slope. And at this point, maximum intensity, maximum slope. At the point C, some important observation. See, at the point C, when I draw the diagram like this, see, there is a slope here at the point C. That slope should be equal to intensity here 63. After coming down, again you have to go this way. Again remember, these two tangents should be parallel to each other, because for whether you find shear force to left side or right side, intensity is 63. So both of them slope should be same. See, important observation. So if you draw tangent here or tangent here, both should be parallel. Okay. Those who are interested, make a note. These are called finer points. Suppose you go to interview, they can ask such questions. Then if you correctly answer, they will be very much impressed, because they will feel this person knows everything systematically. Okay, now, anyway, safer side, show calculation, shear force calculation. Shear force at A, slightly come inside, plus 162. Shear force at C, one note you have to write. I am not writing. At C, there is a point load, shear force twice. First point shear force just to left of C, 162 minus half into 7 into 63. Then just to right side is same answer, minus 40. Shear force at B slightly inside. How much? The previous answer of minus 98.5 minus this much load will give shear force. Or you can do write one thing. If you slightly look that side, if you slightly come inside and look that side right up is negative. See, same answer. Now, SF variation is parabolic of second degree for AC and CB. Note, go back and draw shear force diagram. Already drawn. Now, further you have to write. Observe the shear force diagram. Is the shear force diagram crossing the baseline somewhere? Yes. There is a zero shear force point. I can write here only, but no, I don't want to disturb this one. So, next statement is location of the point. Location of point where, location of point, one more thing. Point, between which point? See here, it is between A and C. That is equally important. Between A and C, where shear force equal to 0. You can write here. Reason. This is to completely define the shear force diagram, you have to locate that point. Second one. Later, this is going to be the point where bending moment is maximum. So, that reason told endless number of times. Start. Now, let shear force be 0 at a point X. At a point X, comma, at X from A. X from A. As shown. Put one sketch here. To understand correctly, put one sketch. Actually, there only you can enter. But no, I do not want. I want everything here only. To make it complete control. Or after practicing, you can mark X here only. See, this reaction is 162 kilonewton. That is not required for me. This is A, this is B. This is 90 kN per meter. And this is where the point load is there. This is the point C. That also not required for me. The shear force is 0 somewhere here. See. Somewhere here. Okay. I already told you it has to come 6 meter. Otherwise, I will be in trouble. People will be laughing. He told something you will get. Did not get it. Let us see. Okay, now. At this point, intensity required. This is W intensity at X. Okay, right? Next statement. Let W suffix X be intensity of UVL at the point X. Okay, now W suffix X, I should not explain this one, equal to 90 by 10 into X. Sorry, I am not explaining. 90 by 10 into X or equal to 9X kilonewton per meter. Okay. Enter here, equal to 9 times X kilonewton per meter. Then further, now you write to locate the point, this point X, or to get the value of X, equate shear force at X to 0. How many times I told, I don't know. So I am skipping those statements. Those who are serious should write all those things. Over. Now, therefore, shear force at X equal to left side plus 162 minus this much load. How much it is? Half into X into 9 times X is the shear force. Okay. This should be equal to 0. Therefore, you get the value of X. I am not checking. It has to come 6 meter because I told in the beginning, I set the question to get 6. Anyway, for your satisfaction, 162 into 2 divided by 9 equal to root answer. It is 6 meter. I will not give such commitments unless I got confidence. So, one statement right here. Therefore, you write shear force is 0 at 6 meter from A, and also write, or that is the point where bending moment is maximum. Over. Now, lastly, substitute, because you require further calculation. X equal to 6 meter, you get intensity at X equal to, where is it? 9X. 9 into 6 equal to 54 kilonewton per meter. Now, enter all this. X equal to 6 meter, we already got. Then this equal to, how much I got? 54 kilonewton per meter. Over. Now, last part, go for BM calculation. Over. Sagging positive, bending moment at A equal to 0. Next, you want bending moment at C equal to, see here, standard point C. This distance, you can see here, not there. You can see here, at bending moment here. Plus 162 into 7, plus 162 into 7, minus moment of this much load. Half into 7 into 63 into bracket 1 by 3 of 7 over. This will come, I already calculated 619.5 kilonewton meter. Okay, 1 minute now, let me check also. Because if something is wrong, actually not required. Half into 7 into 63 into 1 by 3 of 7. That one is subtract from 162 into 7. Yes, 619.5 kilonewton meter. Now, our bending moment at B equal to 0. All standard points are over. Now, also, this I am telling from beginning, whatever you write, note you write. Apart from the standard point, we also need bending moment where SF is 0. Also, BM at X. You write there. This is going to be the maximum BM for the beam equal to plus, refer the sketch, plus 162 into 6 plus 162 into 6 is the positive bending moment minus moment of this much load minus half into 6 into 54 is the intensity there. Half into, this is total load multiplied by 1/3 of 6. Okay, let me calculate that also. Say per side, 162 into 6 minus half into 6 into 54 into 1 by 3 of 6 equal to 648 positive. I use red color. 648 kilonewton meter. Over. Right, this is the maximum BM. Now, what you do is variation. Lastly, BM variation is parabolic of what degree? Third degree for, Some will tell from A to this point, this point, this point. No, this point is not a standard point. A to C, single curve for AC and CB. Or from A to C, simply one smooth curve should come. This is a peak value. If I draw tangent here, slope 0. When you reach here, it will come to 619. Okay, over. Now, right, go back and draw BMD. I drawn the BMD here. See, here more slope, here less slope, and one more thing. See, at this point, slope for this side is 58.5, slope for that side is 619. Because of the small difference, not able to maintain, or I'll tell you, see, when you end there, it will come this way. Next slope will be this way. See, here lesser slope, there higher slope. That all you make a note. Okay, this question is completely over. Now we will go to next class, class number 79. Same thing, I will shift not this point load. I will put one more point load somewhere here so that I will get SF 0, not 0. At that point load itself, SFD will cross the baseline. So there, the headache of locating the point is not there. Short class. Per class, one problem only, I decided. Instead of doing multiple problems, it is better to have one class, one problem for one class. Okay. Next class, I will go for point load here. So SF, that SF will be 0 after the point load. Just for information for you, see. When you find BM at C here, we look this side. 162 into 7 minus half into 7 into 63 over. Or if you want, if you got courage, you can look right side. I will tell the answer. See, 328 into 3 minus 63 plus 90 divided by 2 into 3 is the total load into 63 plus twice of 90 divided by 63 plus 90 into 3 by 3. Answer is 619.5 KN meter. I am not calculating because it has to come. Okay. Now, we will meet in class number 79. Thank you for going through the class.